Welcome to Day 3 of Math 111. Today we're going to talk about problem solving. We're going to look at a couple of problems. We're also going to talk about techniques of problem solving and some of the history behind the techniques that we use for problem solving. The first kind of problem that we want to introduce is that of a magic square. The kind of magic square that we're looking at is going to be an array of 9 numbers, 3 rows and 3 columns. And you'll notice here in this example that we've got the numbers 2, 3, 4, 5, 6, 7, 8, 9, and 10 arranged in the magic square. What makes this a magic square? When we look at the row totals, we'll notice that each row sums to 18. I'll give you just a moment to verify. We also look at the column totals and also notice that each of the columns has a sum of 18. And then we also have the diagonals of the square, and they also have a sum of 18. So as you can see on the screen, a magic square is a square array of numbers in which each column, each row, and the 2 main diagonals all add to the same number. The magic squares are not unique. So as you can see here, we've got the original magic square on the left and then 2 additional ones where we have repositioned the numbers, and we still have magic squares. And you can verify each one of these. You will notice that for each one of these squares, the row total is 18, the column total is 18, and the total along the diagonals is also 18. So there's more than one solution when creating a magic square. I'd like for you to create a magic square using these numbers. These are the integers 21 through 29. I'm going to give you a hint. Try using the previous magic square and just replacing integers in that magic square with these new ones and see if you can come up with the solution. What I would like for you to do now is pause the video while you work on this problem. The solution will appear in a few seconds, but for now I'd like for you to pause the video and work on this on your own before you look at the answer. I hope that while you were pausing the video, you were able to get the solution. This is one possible solution for the magic square. Did you get it? I hope so. We're going to spend a few minutes talking about problem solving and an important person in mathematics education history who really pioneered some work in problem solving. His name was George Polya, and he was a Hungarian mathematician. He immigrated to the United States in 1940. If you think about your world history, you'll know that that was a tumultuous time in Europe with the World War. And so the United States gained from his immigration to the United States. Dr. Polya wrote a book, How to Solve It, in 1945. And in this book, he delves into 4 steps for solving problems. The first step is understand the problem. The second step is devise a plan. The third step is carry out the plan. And finally, the fourth step is look back. Let's spend a minute on each one of these steps and get an idea of what Polya was saying in his book as he talked about these 4 steps. Step 1 is to understand the problem. It's very important for students to understand the problem, and you know this from your own experience. If you don't understand the problem, you have very little chance of solving it. So here are some questions that I got from Berkeley that you can ask yourself, or perhaps you can ask students in helping them understand the problem. Do you understand all the words used in stating the problem? You know, it's really hard to get a grasp of what's being asked of you if you don't understand the language. What are you asked to find or show? Can you restate the problem in your own words? Can you think of a picture or diagram that might help you understand the problem? Is there enough information to enable you to find a solution? So these all seem very practical, but they really can help a student analyze what's given to them and determine whether they really understand the problem or not. Step 2 is devise a plan. So once the problem is understood, we need a way to go about solving the problem. We've already mentioned some of these in class in the previous couple of days. You can see a list here of techniques that can be used for solving problems. Guess and check, which is something that you probably used on the magic square. Make an orderly list. Eliminate possibilities. Use symmetry. Consider special cases. Use direct reasoning. Solve an equation. Look for a pattern. Draw a picture. Solve a simpler problem. Use a model. Work backwards. Use a formula. Be ingenious. Again, some of these will seem more elementary to you than others. Some, like solving an equation or use a formula, seem as if they're on a higher level. And that's probably true and would be more useful to more advanced students. But techniques like solving a problem by drawing a picture, or looking for patterns, or guess and check, these are techniques that are particularly useful for elementary students. Step 3 is to carry out the plan. So once you've decided what technique you want to try, then apply that technique and see if it leads you to the solution to the problem. You'll notice here it says persist with the plan that you have chosen. If it continues not to work, discard it and choose another. Don't be misled. This is how mathematics is done, even by professionals. And this is true. Even research mathematicians try things and discard things that don't work. And they work for years and years to find the solution to a problem. Step 4 is to look back. Sometimes this one is omitted. Sometimes we're so excited that we get a solution that we forget to look back. Polya mentions that much can be gained by taking the time to reflect and look back at what you have done, what worked and what didn't. Doing this will enable you to predict what strategy to use to solve future problems. So it takes just a minute or two to analyze what you have done, and then make mental notes about things that worked and things that didn't work. It really does help in the future whenever you are presented with similar problems. You can rely on those techniques that have worked for you in the past. So in the section that accompanies this lecture in the book, you'll see some strategies that we've already mentioned: guess and check, make an orderly list, and draw a diagram. So be on the lookout for these strategies as you work through the homework problems in this section. I want to pose a question to you. What do you think about using calculators in school, in the first grade, in the fifth grade, or some other grade? Think about your own experience and ask yourself if it was maybe the best decision. Some of you may have had teachers who did not allow a calculator, and perhaps you would have benefited if you had had one. Or maybe some of you had teachers that gave you calculators from the beginning, and you think that perhaps you would have been better off had you not had access to the calculator for a while. Anyway, think about this. Think about what you might do as a teacher. Then after you've thought about that for a few minutes, take a look at the position paper that is posted in Canvas for day 3 and see what their official position is.